So this, if you learn it, great. If you don't worry about it. This is just me telling you, hey, why is the formula for standard deviation what it is? So, I mean, where does this come from? And then we'll actually jump back into the homework next time. You remember in your algebra class, like if I have 2 points like that, you remember how to find how far apart they are?
Yes.
How do you do that?
You triangle and
Yeah, exactly. You go like x2 minus x1 there. This is y2 minus y1. So you do square root, exactly. x2 minus x1 squared, y2 minus y1 squared. Right? Okay. That's actually kind of all you're doing when you do standard deviation. I mean, if you actually write out the formula, what is standard deviation? So it's, you add up, well, you take each value minus the mean squared, and then divide by n, or n minus 1, and then take the square root of it. It looks really ugly. But that's actually really, it's just the distance formula. So it's saying, okay, if I've got like, well, let's just do the one I just did. I had 10, 11, 12, 13, 14. What I actually do, I went 10 minus 12 squared, 11 minus 12 squared, 12 minus 12 squared, 13 minus 12 squared, 14 minus 12 squared. So, and then square rooted it, right? All that is, that's just the distance, like back in algebra, between the point 10, 11, 12, 13, 14, and the point 12, 12, 12, 12, 12. I mean, it's kind of the Pythagorean theorem on steroids because there's 5 of them, but it's just, yeah, subtract all the x's, the y's, the z's, the w's, and the q's, I mean, whatever they are. Subtract them, square them, add them up, take the square root, right? So why does that seem like a good thing to do? Well, if you look at this, if you think about, well, what if our data was 12, 12, 12, 12, 12? You feel like that data is all pretty spread out, or is that pretty close, all pretty close to the mean? Yeah, everybody's equal to the mean, right? So if there's anything in the world that should not have any standard deviation, it's if you have the same number repeated a whole bunch of times. So if we don't know kind of what we should call standard deviation, it's like, oh, well, we just take whatever our numbers are, think about them as some point in a big, however many dimension space, say, hey, how far is that point from the guy where everybody's just equal to the mean? So that's all standard deviation is. It always, well, back in the days before we had Excel to compute it for you, people were always really scared when they had to start doing stuff like that. But, I mean, it looks hard, but conceptually anyway, all it is just the distance formula. It's just bigger because you usually have more than 2 points or whatever. Okay. So does everybody have a rough idea what standard deviation means now? Okay. So anyway, we'll hop back into it on Monday. And as far as actually doing the homework, since we have Excel to help us, it will take like 3 seconds. But you need to have some understanding of what standard deviation is going forward in the class. So I wanted to take a day to talk about it.